Hello guys, my name is Shivraj Sanjay Shangarai. Today I am going to present distributed systems, its definition, characteristics and goals. So let's begin. So firstly, what is distributed system? Distributed system is a collection of independent computers working together but appearing as a single one. Like we have previously used a centralized system in which one server is present and on that server all the devices are connected. Like suppose a banking system where the data of the bank or all application of the bank and the database of the bank all managed by one server. So there is a very high chance to when one server that server mainframe if get collapse or get down, then all the application, all the working of the banking system will collapse. Then we can't easily recover from that. So for that new system which is launched, which is called as distributed system. The key idea behind that, user don't see the complexity. There are multiple servers works behind the one application, like login server, authentication server, application server, database server, website server. There are multiple servers are working behind that, but we see it is as a one server. So that's why it is appear like a one. Users don't see the its complexity behind that, and it look like a one computer which is worked. We see the why do we need distributed systems? Because earlier we use a centralized system which is a single mainframe or single server. We on that multiple clients will be connect to that server and access their data, access their work from that. So the problem in that system is there is a single point of failure. If that one mainframe, one server gets failure, then all the data, all the app will be shut down. Then next is expensive scaling. Suppose we have one server, then if you want to scale it, if client increases, then we need to scale it. But there is one option to scaling is the vertical scaling in a centralized system, because there is a one server, all application are present in that only one server. That's why it is very expensive to buy a new server which has more capacity, more storage, more computing power. And then third is limited performance for multiple users. Because the multiple users can access a one server, it will cause the bottleneck at that server side. So many waiting time, many clients don't get access the server. That's why it has a limited performance if the multiple users can access at the same time. Then fourth is limited performance for multiple users. That's why we are using the distributed systems. Limited performance means it create the bottleneck at the server side. Second, fourth is need to sharing resources across a multiple computer. Suppose we have only one printer, one scanner, and we need to share it with the another other clients, other computers. Then we can't easily share it using a centralized system, because there is a bottleneck due to other works that server need to handle. That's why we going to use distributed systems. That's because of that, other computers, if they want other resources, or any client want the other files, they can access it, which are the shareable. For that we are going to use a distributed system. Like now we see the cloud services, Google search, Netflix streaming, they are all using the clouds, they are using the distributed systems. Now we see the example of distributed system. There are now we see the cutting edge technology, which is a cloud computing. They are basically in cloud computing is a distributed system is a base of the cloud system. First distributed systems comes, and from that the new idea cloud computing is generated. So all the platforms are working worked as worked as a distributed systems. So in cloud platforms, then e-commerce platforms, all we see the e-commerce giants like Amazon, Flipkart, and new incoming like Misho, Mintra. They are all using a distributed system to handle more customers. Then social media platforms like Facebook, WhatsApp, Instagram, they have many requests comes at a time. So to handle that many requests, they use the distributed system at different locations, so the user get easily response from the server. Now next is the characteristics of distributed system. See, the characteristics of the distributed system is first is present single system image. Means if we see the distributed system, we see at it is as a one single system. It will but behind it there are multiple systems present, multiple servers are present, and they will connect to each other. Then second characteristic is transparency. Hide internal details from user. Here transparency means like glass. If we see glass, then we only see that. That's why this is called transparency, because if we see the internal details, then only we see the other servers are present. But if we not seen, we see only the one server is present behind the application. Third is easily expandable. If we going to expand the distributed system, then we need to horizontal scaling. That is very cheap, that is very cost effective, cost friendly, because we buy a new server and we connect that previous server. So instead of wasting the previous server, we just connect the new server. So it is easily and cost friendly. And fourth characteristic is continuous availability, because if suppose we use distributed systems, and if suppose one server get fail, then another servers are present. That's why it very less chance to it will not available. It is continuous available, it is always present. Then for fifth characteristics is middleware support, which provide communication and coordination between computers. Here computers means servers. Like suppose we are going to log in with the one server, but it will create a one session ID, and that session ID we use in the database server. That session ID used in the that session ID used in the application server. Means that session ID is created by middleware support that will communicate with the other servers. That's why we use, this is the main heart of the distributed system, which is middleware support. Then next we see the distributed system architecture. This is the architecture of distribution system. How they work, let's we see. First, machine A, mission B, and machine C. There are three machines are present, which is servers. They have their local OS. We can see here they have, suppose first has Windows, second has Ubuntu, and third has also Linux. Then they are connected with the one network, which is maybe LAN, WAN, anything, or with the help of internet. Then we see the one distributed application. Distributed application means you can consider it is as any e-commerce application or any banking application, like e-commerce Amazon application we can consider. Then middleware service is a heart of the distributed system, which communicate between other servers. We create session ID. For the once login, we can access the all systems, all servers. So if we take example, suppose I want to log in with the on the Amazon server. So when I am login, so that's why for that I am using a machine A which has a local OS, and from that it will create the my login by checking my credentials. And where distributed middleware service can create my session ID, which will pass to the machine B. So machine B is for the application distribution rendering. So it will using that by my that ID, it will give me the my data. Suppose machine C is for database, so machine B can access machine C data or a database with that ID. So that will middleware service can do for the communication between different servers. Then we see the goals of distributed systems. There are basically four goals which need to fulfill by the distributed system. The first is resource accessibility. Resource accessibility means we see the as previously, everyone should access at any cost at any time all the resources anyone can need to access. This is the main goal of the distributed system. Then distribution transparency, all the internal hiding details, it should not be the seen to the users. The only users only see the one application which is run, but before backend add that backend, how many servers, how they will process, that will not be shown. The third is openness, this system will open to all. Then scalability, we should scalable as a horizontal. We can add multiple servers, we can add multiple databases, we can add multiple computation power for that. So we see one by one. First is resource accessibility, meaning access remote resources easily and fairly, like printers, files, CPU cycles, etc. So the benefit of that is economical share expenses resources. Suppose one printer used by all computers, then the printer get, we can we can use that printer very much time, and it is economically beneficial, because the we not buy new computer for each node. Then example like printer sharing in office or shared databases. Challenges is security issue while sharing, because there is a our data is present on multiple servers. That's why it is a very high chance to security issues. Then next is distributed transparency. This is the second goal. System hides the complexity and distribution. Second is appears as a one computer even if resources are spread worldwide. That we seen earlier. Then third is user should access local and remote resources in the same way. Suppose we have a local server and we have other servers are present on the other side, or which is present as a shared servers. So they are appear like a same. It is come from the same server. Then third is user should access for this example, like cloud storage, Google Drive local, like looks like a local folder. Example is Google storage, like a Google Drive. If we store our photos or files on a Google Drive, we there are stored in a multiple servers. There are 256 servers present at Google for the Google Drive only, and which is we don't see which server my one file is present on which server and second file present on that server. This is we can't see that. We just see one application in that my files are present continuously. We can't see the internal complexity. This is the goal of the distributed system. Then next is openness. Openness means service follows standard rules and interfaces. Then enables communication between different OS hardware and languages. For that, it will use RPC, remote procedure call, which is a machinism in distributed system, which is a mechanism in a distributed system. Then here client will connect with the server and they can communicate with the call packet, which is called a remote procedure call, and the result packet, which is present from which is gives from server to client. Then key features of that openness is interoperability, means different system work together. Second is a portability, means same app runs on multiple systems. Then third is extensibility, easily add new features, new servers and all these things. Then example, a Java program on Linux communicate with CPP plus program on the Windows using RPC, remote procedure call. Fourth is scalability. If we use centralized system, then we have only one chance, only one scalability to, which is vertical scalability. Means we cannot add multiple servers. We just increase only one server. But if we use distributed system, we have two type of scalability, which is vertical and second is horizontal. Vertical means we increase the power of one system only. And horizontal means we can add more systems. So this is two options are available in distributed system, and that's why it is a cheap and expensive, not a very expensive. Then we see the definition. System can handle growth, more users, data, resources. This is the scalability because of increasing servers power. Then challenges to scalability. First is centralized server. When centralized server, then there is a bottleneck. If the many client access the server at a one time, then if a centralized database, then traffic issues are present due to the many servers give requests at a time. If distributed system solve this by load balancing, replication, and partitioning. Load balancing is a very cutting edge concept where we can increase the power of the server at a runtime, so it will not create a bottleneck. Replication means if the server's data is present at the multiple servers. Suppose one server is busy, then other servers can give that data to us. Second is e-commerce. Example we can see e-commerce website scaling during the festival sales. Like festival sales, like a festival sales are present, then there are multiple e-commerce websites like Amazon, Myntra. They can scale at that time only, so they can increase their servers powers, etc. Like we have other example like ClickBuzz only scale his data, his scale only the servers when the IPL starts, otherwise it will use less servers. Then we see the advantages of distributed system. First advantage of distributed system is the resource sharing, that we see for that we see in the last slide. Second is reliability, no single point of failure. One server get failure, though other servers are present that will handle that thing because of replication. scalability, we can grow horizontally and vertically both way. Then flexibility, multi-platform support, we can there are multiple platforms are supported because of middleware. They can communicate with each other using of middleware. Second, fourth is cost efficiency, use commodity hardware. Obviously there is a cost efficiency because during the scaling we are using a horizontal scaling. Now we see the challenges of distributed system. First is security concerns. There are multiple servers are present in a distributed system. That's why we need to secure all servers. And maybe if there are shared servers, then there is a lot of chance to security concerns. There should be a system which get hacked, or the data will breaches. Data breaches will happen. Then complexity in design. User can see only the one server, but at the backend there are multiple servers are present. So to design it, it is very complexity. So it has very large complexity. The network issue, latency. If one network get fail, or latency will during the communication, then it will create a network issue. Then synchronization of data. There are multiple server present at multiple locations like US. One is in India. So to communicate between that, there is a time difference. So here the time is different, and the US time is different. So there is synchronization. We need synchronization between them. Fault detection is difficult because if one server get fault, we can detect it which server is fault, or we can detect fault. This is a very difficult in distributed system. So real life case study. We know the Google has a lot of Google get a lot of requests at a single second. So how they can manage it? Because of distributed system, there are multiple servers present at the Google side, and each server can handle multiple users, multiple client, and only one server is dedicated to just handle the client. To get a request, another server is the application server which provides the result of that. So there are multiple servers work behind Google, and which is work as a distributed system. That's why here say there are multiple distributed servers handle a request in parallel way. Then second is Netflix. Netflix uses distributed server across the global for streaming without delay. We can see Netflix movies or web series without delay because of distributed systems. They work parallelly. Then summary, what we see up to now. First is distributed system is equal to independent computers acting as a one. We see that. Second is key characteristic, transparency, expandability, availability. Then goal is resource accessibility, transparency, openness, scalability. And the real world example, we see the internet, how it works, cloud, banking, social media. Another we see the Google, how it works. Then we see the Netflix, how it works.